July 2016 was the hottest July ever recorded. Same with June, and also May. April though, April was also the hottest April. In fact, every month going back to October 2015 has been the hottest since 1880. Cue the Nelly.
It's getting hot in here.
It's hard to argue Earth isn't heating up because unless you have a neck problem, it is. But what's really warming the Earth? The climate's a complex system influenced by everything from our orbit to gases in our atmosphere to volcanoes. And when we say warmer, warmer compared to what? For most of history, temperature records look something like this. Hot today, hotter than yesterday, gonna be hot tomorrow. But with the development of accurate thermometers and standardized temperature scales in the 1700s, we could finally get some real data from ships crossing the ocean, weather stations around the world, #colonialism. But weather isn't climate, and a few temperature records do not a complete global climate history make. It wasn't until the mid-19th century that we were collecting enough data in enough places to figure out an average temperature for the whole world, which is why US climate graphs start here while the UK goes back to here. Should we believe what Ben Franklin or Thomas Jefferson wrote in their weather journal? Can we really trust all those old records? Well, these are good questions, but climate scientists have looked at the data through many different lenses, and every time they do the math, they get the same answer. Earth is warming up fast. But none of this explains the cause. It could be human activity, but it could also be so many other things. Earth's orbit is pretty wobbly. Our elliptical path around the sun spins like a hula hoop. Earth's axis draws a circle every 21,000 years and wobbles back and forth every 41,000. And all these affect Earth's climate. But scientists understand these changes really well, and when they use them to predict climate change, they don't see any. The sun provides almost all of Earth's heat, and it also changes in cycles, dimming and brightening, sort of like a light bulb. For most of the last 1,000 years, when the sun turned up, temperatures rose on Earth, and when the sun dimmed, temperatures fell. But in the past few decades, the sun's been cooling slightly, yet Earth keeps getting hotter. Solar activity can't explain today's climate change. We know carbon dioxide traps heat in the atmosphere, and the last time Earth's CO2 levels were this high, Homo sapiens didn't exist. But maybe all this CO2 is Earth's fault. When volcanoes erupt, they release tons of the stuff, like little magma-powered earth bursts. Geologists measured how much, and it turns out humans release about 100 times more CO2. Volcanic activity can't explain climate change. Some things actually cool the Earth. Cutting down more trees makes Earth's surface lighter. It reflects more light back into space. Clouds, pollutants, and aerosols in the atmosphere do the same thing. They make our atmosphere reflective, so less radiation gets in. Yet even with these cooling effects getting stronger, Earth's getting warmer. But we know that greenhouse gases like CO2 and methane have skyrocketed. And when we calculate how temperatures should change based on those levels, we finally see a rise. Subtract the cooling from trees and clouds and pollution, and it matches more than a century of data. This isn't magic, it's math. These climate graphs don't show absolute temperatures because absolute temperatures, the number on a thermometer, can be misleading. The top of a mountain will always be colder than the valley below, but if they're both a degree above normal, it gives us a hint that the larger climate might be different. And this is why we look at the anomaly. How different today's average temperature is from the average temperature somewhere in the past. The degrees above normal. But what is normal? The last month Earth's temperature was below the 20th century average was December 1984. Many of you haven't seen below average temperatures in your lifetime. July 2016 was the 379th consecutive month and the 40th July in a row of above average temperatures. Yet you've probably heard more news lately about breaking Olympic records than climate records. Are we really just used to this? In 1995, biologist Daniel Pauly coined the idea of shifting baselines. The idea that we evaluate change very differently depending on what we're comparing to. Today, about 500,000 bison live in North America, a remarkable recovery from the late 19th century. But compared to the 20 to 30 million that roamed the plains before 1600, our bison baseline suddenly paints a very different picture. We know how hot Earth has been over the past century and a half. We have the data. Scientists understand that Earth's climate is a complex puzzle whose pieces affect one another in many ways. When they put those pieces together to recreate that history, to find a cause, the picture is clear. Let's take a long, hard look at it. Stay curious. Hey guys, this is not a green screen. I'm in Switzerland. Hope you enjoyed this week's video. The data that we use in all those graphs comes from NASA's Goddard Institute for Space Science. And we adapted it from an awesome visualization done by Bloomberg. There's links to all of that down in the description, as well as a ton more references in case you want to learn more. We've also got some other climate change videos that I think you're going to want to check out. Not only about why climate change is happening and why we know that, but why some people don't always believe in it. Now, if you'll excuse me, I have to go check out these mountains before they melt. Stay curious.